Hi everybody, welcome back to the unit AC Fundamentals. In this unit, I would like to give you a complete behavior of resistance connected to AC source. It is called as AC through pure resistance alone. At the end of this video, you will be able to explain the behavior of resistance connected across an AC source, identify the expressions for voltage applied, current, power for resistive AC circuit, and analyze the vector and phasor relations between the voltage, current and power for resistive AC circuit. Before going to the topic, I would like to explain what is a resistance. The electrical resistance is the property of a material by virtue of which it opposes the flow of electrons through the material called resistor. It is indicated by the letter R. Now coming to the topic, this resistance is connected to AC supply, that is alternating current. Consider a resistance. It is connected to the AC source of an instantaneous value of voltage V is equal to V max sine omega t. Consider it as equation 1. By the applying of voltage, the current flows through the circuit, that is of resistive circuit. The current flows in the circuit I is equal to V by R. Let it be the equation number 2. Substitute 1 into I is equal to V max sine omega 2 t by R. Consider as equation number 3. The value of I is maximum when sine omega t is equal to 1. Therefore, I max is equal to V max by R. That implies I is equal to I max sine omega t by the consideration of equation number 3. I is equal to I max sine omega t. So, by the observation of 1 and 4, that means consider the above expression as fourth expression, I is equal to I max sine omega t. By the observation of 1 and 4 equations, it is observed that the applied voltage and the current flowing through the resistance are in phase with each other. Then, by the observing of the vector diagram is, consider the origin point, consider the V as the reference, and the current value is in phase with the voltage. That means the two lines, the two vectors will be lie on the same line. And the waveforms are, consider the origin point, consider the x-axis as omega t, and on the y-axis consider the voltage and the current. And we are observing that the voltage waveform and the current waveforms, the two are in phase. Those two are in phase. Okay. Then coming to the power, then the power consumed in the resistance circuit at any instant is equal to the product of the voltage and current at that instant. Therefore, instantaneous power P is equal to V into I. Let it be the equation number 5. Substituting the value of V and I in the above expression from 1 and 4 expressions, we will get that P is equal to V max sine omega t into I max sine omega t. Rearranging of this expression, V max I max sine square omega t. Here, in this expression, we have to be written this sine square omega t into 1 minus cos 2 omega t by 2. Then the expression will be coming as V max I max 1 minus cos 2 omega t by 2. By the rearranging of this one, we will get the expression as Vmax Imax by 2 minus Vmax Imax cos 2 omega 2 by 2. From the above expression, that is this expression, it is observed that the instantaneous power has two parts. The first part is called the constant part and the second part is called the fluctuating part. From this, the frequency of the fluctuating part is twice the applied voltage frequency. For a complete cycle, the average value of Imax, Vmax cos 2 omega t by 2 is 0. Therefore, the average power in this circuit is P is equal to Vmax Imax by 2 watts. This can be represented by P is equal to, I am written the 2 as root 2 into root 2 and we have to be represented this one as Vmax by root 2 into Imax by root 2. I am considering Vmax by root 2 is equal to V and Imax by root 2 is equal to I. This V represents the RMS value of applied voltage and the I represents the RMS value of the current. And this P is equal to finally V into I, watts. The meaning of this equation is for a pure resistive circuit is equal to the product of RMS value of voltage and current. Therefore, power factor, it is represented with the cos pi, is equal to 1. That is, the phase angle difference between voltage and current is 0. The conclusion of the topic is, the first point, the current flowing through the pure resistance is in phase with the voltage applied. And the second point, the phase difference pi is equal to 0. Third point, power factor cos pi is equal to 1. That means unity. Fourth point, average power P is equal to V into I watts. Thank you.